Hey guys, welcome back to another video, and for today's session we'll be looking at two objectives, and those objectives are calculating moles and calculating molarity. So let's not waste any time and let's get right to the question at hand. Hey guys, so for question 1 it had asked us to calculate the mass of 6.022 times 10 to the 23 molecules of calcium carbonate, and we're given the number of molecules, which is 6.022 times 10 to the 23, and the molar mass of calcium carbonate, which was calculated to be 100.086. And to do this question, we will first need to find the number of moles. So we will now say moles is equal to 6.022 times 10 to the 23 divided by Avogadro's number, which has a value of 6.022 times 10 to the 23 as well. So 6.022 times 10 to the 23. And when we have done that, we will now have found the number of moles for calcium carbonate to be 1 mole. Right? So let's continue. To find the mass, we will now have to say mass of calcium carbonate is equal to moles, which is mass divided by the molar mass. And what we'll do now, we will transpose and we'll make mass the subject of the formula, and we'll now say moles. So mass is now equal to moles times molar mass. And of course, from the first question, we found that the moles of calcium carbonate is 1. So we say 1 moles times 100.086 gram per mole. And of course, from this question, moles will cancel mole, and we will now have an answer for the mass to be equal to 100.086 gram of calcium carbonate. And that is your answer for this question. And let's move on to the next question at hand. So for question 2, it had asked us to calculate the number of oxygen atoms in 1 mole of oxygen. So 1 molecule of O2 is equal to 2 oxygen atoms present. Therefore, since we know this, we can say 1 mole of oxygen is equal to 2 mole of oxygen atoms. And we're now going to use the equation moles is equal to the number of particles divided by Avogadro's constant, which I had stated that had a value of 6.022 times 10 to the 23. So now we're going to transpose and make the number of particles the subject of the formula, and we're now going to say moles times Avogadro's constant. Therefore, since we know the number of mole of oxygen is 2 moles times 6.022 times 10 to the 23, this is going to give us an answer of 12.044 times 10 to the 23 oxygen atoms in 1 mole of oxygen, O2. And that is how you will do this question. So first, as I said, one molecule of O2 has two oxygen atoms present, and therefore 1 mole of oxygen is therefore equal to 2 mole of oxygen atoms. And then we transpose and we made number of particles the subject of the formula, and we now derive that our answer to be equal to 12.044 times 10 to the 23 oxygen atoms in 1 mole of O2. Question 3 had asked us to calculate the number of copper atoms in 0.635 gram of copper, and we are given the mass of copper, which is 0.635 gram, and the molar mass of copper, which is 63.546 gram per mole. And to do this question, we first need to find the number of moles of copper first, which is moles is equal to mass divided by molar mass. And we're now going to substitute the values for the mass, which is 0.635 grams, and the molar mass, which is 63.546 gram per moles. And we're now going to cancel the units of grams, so grams cancel gram, which leaves moles. And when you put this in your calculator, you should get a value of 0.00999 moles of copper, or you could simply round this off to 0.01 mole of copper. And now that we've found the moles of copper, we now can therefore use the same equation again, but this time we're going to use it to find the number of particles. So we're going to say moles is equal to the number of particles divided by Avogadro's constant. Now we're going to transpose and make the particles the subject of the formula, which is the mole times Avogadro's constant. Therefore, as we said, we calculate the number of moles of copper, which was 0.00999 moles of copper, and therefore we're going to say the number of particles is equal to 0.00999 moles times 6.022 times 10 to the 23 particles, which, if you put this in your calculator, should give you a value of 6.016 times 10 to the 21 particles of copper atoms. And this is your answer to this question. And we now move on to question 4. For question 4, it has asked us to calculate the number of molecules in 11.2 liters of sulfur dioxide gas at STP. And STP simply means standard temperature and pressure. And to this question, we're given the value of 1 mole of sulfur dioxide to be equal to 22.4 liters, which is the STP value. Now, to do this question, we now have to say moles is equal to volume divided by the molar volume. And the molar volume is the STP value. So the molar volume is the STP value, and so forth. We're going to now say that moles is equal to 11.2 liters divided by 22.4 liters, which, if you put this into your calculator, you should get a value of 0.5 moles of sulfur dioxide. Okay, now the question still asks us to calculate the number of molecules. So to do this now, we're going to use the next mole equation, which is the number of particles divided by Avogadro's constant. Now, of course, we know that we're going to put the number of particles as the subject of the formula, which is moles, which is 0.5 moles of sulfur dioxide times 6.022 times 10 to the 23 particles, which should give you a value of 3.011 times 10 to the 23 number of molecules present in 11.2 liters of sulfur dioxide. And this is how you would do question 4, and this is your answer to question 4. For question 5, it had asked us to calculate the volume of 20 grams of hydrogen at RTP. And of course, RTP simply means room temperature and pressure, which has a molar volume of 24 liters. So the first thing is that we write down what's given, which we are given the mass of hydrogen, which is equal to 20 gram, and the molar mass of hydrogen as well, which is 2.016 gram per mole. Therefore, with these two values, we can find the moles with the mass divided by molar mass. And we substitute our values, which is 20 gram divided by 2.016 gram per mole. And we should get an answer of 9.9 moles of hydrogen. Now that we found the number of moles of hydrogen, we can now find the volume of hydrogen, which is moles is equal to volume divided by the molar volume. And we're going to transpose and make volume the subject of the formula, and it's going to be moles times the molar volume. Now we have the number of moles, which is 9.9 moles of hydrogen times the 24 liters from the RTP. Remember, I said that RTP simply means 24.24 liters. Sorry about that. And therefore, we can now proceed and put this in our calculator, and we should get a value of 237.6 liters, or you can put in dm cubes of hydrogen. And this is how you will do question 5, and we will now proceed to question 6. So for question 6, it had asked us to calculate the mass of sodium hydroxide needed to prepare 100 milliliter of 0.1 mole concentration of sodium hydroxide. So from the question, we are given the volume and the mole concentration, which is, so let's like we're given, which is the mole concentration, which is 0.1 m, and the volume, which is 100 times 10 to the negative 3 liters. And from these known, we can use the mole concentration equation, which is mole divided by volume, and we can substitute this and put moles as our subject. Hence, we're going to get mole concentration times volume. And we're going to write our knowns, which is the mole concentration, which is 0.1 mole per liter times 100 times 10 to the negative 3 liters. And when we put this into our calculator, we should get an answer of 0.01 moles of sodium hydroxide. Now that we have found the moles of sodium hydroxide, we can now find the mass. And we are given the moles as calculated previously, 0.1 moles, and the molar mass of sodium hydroxide, which is 39.997 gram per mole. Now we can use the mole mole equation with the mass divided by the molar mass. And we substitute and make mass the circle of the formula where we have mole times the molar mass, and we substitute again, we'll get 0.01 moles for the sodium hydroxide times the 39.997 gram per moles of the sodium hydroxide. So we know moles cancel moles, which leaves us back with grams. Therefore, when we put this into our calculator, we should get an answer of 0.4 grams of sodium hydroxide. And for question 7 and last, it asks us to calculate the standard molar volume of oxygen gas and the density of O2 gas at STP is 2.529 gram per liter. So important, always write what's given. So the density is equal to 2.529 gram per liter. The volume, which is equal to X, because that's the unknown, the mass of oxygen, which is equal to 31.998 grams. So from this we can now find the density, which is equal to mass divided by volume. Hence we make volume the circle of the formula and we say 39.998 gram divided by 2.529 gram per liter. So we cancel the common units and we are now left with liters. Therefore, we now can say that when we put this into our calculator, volume is equal to 12.65 liters. And this is how you will solve this type of question, and this is where this presentation will end. Alright, so you have made it to the end of the video. Please do not forget to like, share and subscribe, and stay tuned for more videos like these on Chem with Zach.